Welcome back students to another video lesson from the chapter Sound. Today we shall begin our discussion with the topic reflection of sound waves. Sound waves, like light waves, also get reflected from hard surfaces, which may be both plane or spherical. During reflection, sound waves obey the laws of reflection, that is, the incident sound, the normal at the point of incidence, and the reflected sound all lie on the same plane, and angle of incidence is exactly equal to angle of reflection. The reflection of sound from a hard surface can be observed by performing a simple experiment using a setup as you can see in this picture. For this, we require some cardboard pipes of same length and diameter, a source of sound which might be a stopwatch, a wooden board will act as a reflector. Now as you can see, when the sound of this stopwatch passes through this hollow cardboard tube, it hits this wooden board and gets reflected along this line and is heard by the observer. If we measure the angles formed on both sides so that we get the value of angle of incidence and angle of reflection, that is found to be almost equal. This actually proves the law of reflection of sound. Sound waves have a much longer wavelength than the light waves. Therefore, unlike light waves, sound waves do not need smooth surfaces for suffering reflection. That is why a brick wall, a wooden board, a row of trees, or a hill serve as the reflectors of sound waves. So the question arises, what are good and bad reflectors of sound? Sound is not reflected equally from different materials. Hard surfaces reflect more sound. So hard surfaces are good reflectors of sound, just like metallic sheets, hard plywood, tiles, marble slabs, smooth walls are all good reflectors of sound. Soft or porous surfaces are bad reflectors of sound, such as clothings, curtains, thermocol, cork, soft carpets. They are all bad reflectors of sound. These actually become good absorbers of sound. So, these sound absorbing materials are used to cover walls, ceiling, and floor of auditoriums and cinema halls to reduce reflection of sound. Formation of echo. All of you might have experienced the formation of an echo when you shout your names from a hilltop or in a large hall with a dome shaped ceiling. You hear your own words after a gap of time. This is called echo. The sound returning back towards the source after suffering reflection from a distant obstacle, which could be a wall, a hill, a row of buildings, is called an echo. When the sound is reflected repeatedly from a number of obstacles, more than one echoes, called multiple echoes, are heard. Multiple echoes may be heard one after the other when sound gets repeatedly reflected from distant high-rise buildings or hills. The rolling of thunder is an example of multiple echo formation. Echo is a very familiar example of reflection of sound waves. The time gap between the two sounds, one direct and the other echo, depends upon the medium through which the sound wave travels. Due to persistence of hearing, the minimum time interval between the direct sound and the reflected sound, that is the echo, should be at least 0.1 second. Now as you can see right now in the picture, we have shown formation of echo, and let us try to find out the distance between the source and the obstacle in order to listen to a clear and distinct echo. So if we assume that the distance between the observer and the obstacle is d, and the speed of sound in this medium is given by V. Time after which echo is heard is T. Then time is given by twice of distance divided by V, or using this formula we get distance to be equal to V into T by 2. Now we know that speed of sound at 20 degrees Celsius in air is roughly 343 meter per second. So obviously for an echo to be heard distinctly, time should be greater than equal to 0.1 second. This is due to persistence of hearing. So using these two values, one for speed and one for time, we get the value of distance to be greater than equal to 17.2 meter. So the minimum distance in air at 20 degrees Celsius between the observer and the obstacle for the echo to be heard clearly should be 17.2 meter. The speed of sound increases with the rise in temperature. Therefore, the minimum distance in air between the observer and the obstacle for an echo to be heard clearly at temperatures higher than 25 degrees Celsius is more than 17.2 meter. In rooms having walls less than 17.2 meter away from each other, no echo can be heard. Reverberation. What is reverberation? Let's begin with the basic definition. The persistence of sound in a big hall due to repeated reflections from its walls, ceiling, and floor is called reverberation. The sound made in a big hall gets reflected repeatedly from its walls, ceiling, and floor to produce multiple echoes. When the original sound is overlapped by these echoes, it gets prolonged and persists for a long time. But in the same time, excessive reverberation in any auditorium or hall is not desirable, because then the sound becomes distorted. So, the reverberation can be minimized or reduced by covering the ceiling and walls with sound absorbing materials, by covering the floor with thick or soft carpets, by putting heavy soft curtains on doors and windows, and by using sound absorbing materials in making seats in the hall. Let us study few practical applications or uses of multiple reflection of sound. As you can see in this picture, there is a megaphone, there is a bulb horn, there is a stethoscope. So stethoscope, bulb horn, megaphone, ear trumpet, soundboard, these all are practical applications of multiple reflection of sound. Megaphone, as you can see, is a horn-shaped tube designed to send amplified sound in a particular direction. This is particularly used to address a small gathering. Bulb horn, which might have seen fitted on autos, buses, trucks, it is a wind instrument used by drivers of these vehicles for signaling. So as you can see, when the rubber bulb is pressed, air is forced out through the slit and this produces some sound. When this sound passes through this metallic tube, it suffers multiple reflections and the amplified sound then comes out of the mouth of the horn. Stethoscope is a medical diagnostic instrument based on multiple reflection of sound waves. This is used by doctors for listening to the sound produced inside the body, particularly in the heart or lungs. So you can see in this picture how the sound of the heartbeat is traveling within this tube and it is suffering multiple reflections. So obviously when the doctor listens to this sound, it is an amplified sound. On the same concept, soundboards or curved ceilings and walls in large halls function to produce an amplified sound using the phenomena of multiple reflections. Audible range of hearing. The average frequency range over which the human ear is sensitive is called audible range or range of hearing in humans. The human ear can hear sounds having frequencies ranging between 20 Hz to 20,000 Hz. These waves are called the audible waves. This range of audibility gets narrower as we grow old. In fact, children below 5 years of age can hear up to 25,000 Hz. Infrasound. The sounds having frequencies less than 20 Hz are called infrasonic waves. You can see in this picture few sources of infrasound. Earthquake waves are infrasonic waves. Rhinoceros communicate using infrasonic waves having frequencies less than 5 Hz. Whales and elephants also produce sound in the infrasonic range. What are ultrasonic waves? The sound frequencies greater than 20,000 Hz are called ultrasonic waves or ultrasound. The ultrasonic waves can be produced by applying an alternating electric field to a quartz crystal. Many animals, such as dogs, bats, dolphins, can hear ultrasonic frequencies. Certain moths can hear high frequency squeaks of the bat. The question arises, why is ultrasound so useful? Ultrasound are found very useful because they are high frequency sound waves. So, obviously, these waves have short wavelength. These short wavelength sound waves can be reflected back from the smaller objects. Thus, ultrasound can detect small objects that are less than 1 centimeter size. The sound waves in the audible range cannot detect such objects, smaller than having size ranging from a few tens of centimeters to a few meters. Similarly, ultrasound beam is more directional and can be aimed towards any target just like a torch. So, these waves remain undeviated over long distances. Let us understand few applications of ultrasound. Ultrasound is used in sonar for sound navigation and ranging. The word sonar stands for sound navigation and ranging, and it is a technique that uses ultrasound to measure distance, direction, and speed of underwater objects such as hills, valleys, submarine, iceberg, sunken ships, etc. In fact, trawlermen use ultrasound to find a shoal of fish in the sea. It is used by bats. This is called echolocation. Bats use this technique to find their prey. Ultrasound is used for cleaning very small objects like parts of watches. Actually, in this method, the object to be cleaned is kept in the cleaning solution and the solution is subjected to ultrasonic waves. The high frequency waves stir up the dirt particles and they get detached and the object is thoroughly cleaned. It is used in the field of medicine. It is used for imaging human organs. For example, in echocardiography, which is a medical diagnostic technique, ultrasonic waves are used to construct the image of the heart. It is also used to check the fetal status. It is used for removing kidney stones. So it has got wide range of application even in the field of medicine. Ultrasound is used for detecting flaws in metal casting and automobile tires. So several uses of ultrasonic waves are there. So this will be all for today's discussion. Thank you.